Greetings. As far as Hooke's law, when there is a spring, to stretch it, a certain force has to be created. And from that comes this formula that basically says the force needed to stretch it is equal to the spring's constant. Different springs have different constants, saying how much force each meter of stretching it will actually cost, and x is by how much it is stretched. So this is basically this time distance stretched and or extend, and k is the spring constant. Okay, of course it can be denoted by different letters, so let's say c as well, and so on. X is the length to which it is stretched. So let's say I'll give an example. Let's say I'll give a particular string which has a spring constant of 0.8, and it is supposed to be stretched by for a distance, or it's supposed to be stretched for 5 meters. And so what will be the force needed to stretch it in that length? Well, that will be precisely x times k. So the spring constant is 0.8, then the newtons per meter, alright, and then the distance is meters, so it is times 5 meters. Alright, so this gives 4 newtons. So if the spring constant is equal to 0.8, then to stretch the spring for 5 meters, 4 newtons are required. Alright, a force of 4 newtons has to be applied. Now, let's give a different example. Let's say I stretch it with a force that equals 300, or let's say 900 newtons. Alright, and I stretch it only by 3, or let's say by 9 meters. Alright, so again I can use the same law. X times k, where k is the spring constant and x is the length by which it is stretched. So this example, what it says is, I apply a force of 900 newtons on that spring, I'm pulling it with that force, and the extent to which I'm able to pull it with that force is 9 meters. And expecting that all is normal, I can, using this formula, find the spring constant from it. So either I can plug in here and then divide both sides by, in a manner that I only get the k on one side later, or I can do it straight away. So this formula is exactly the same one that got used a minute ago, is F equals x times k, distance stretched times the spring constant. And so if I divide both sides by x, then F over x equals to k. And I can count for k. So because I have these two pieces of information, F and x, I can create this formula for k in terms of them too. And so now I can calculate the spring constant. It will be 900 newtons over 9 meters. And so it is 100 newtons per meter. That is the spring constant for this one. Alright? So this is the result for such a, let's say, little bit different example in which the formula also has to be changed a bit.